On January 23, 1960, two men sealed themselves inside a steel sphere 6 feet wide and started falling. Jacques Piccard and Don Walsh took close to 4 hours and 48 minutes to reach the bottom of the Challenger Deep. On the way down, somewhere past 32,400 feet, a plexiglass viewing port in the entrance tube cracked. Walsh described the sensation as a mild earthquake moving through the hull. They shut off the instruments, waited in the dark to hear if anything followed, and when nothing did, they looked at each other and kept going. When they landed, there were nearly 36,000 feet of water above them, close to 7 miles, and the silt they disturbed on landing was so fine it never fully cleared. Walsh described the visibility as sitting inside a bowl of milk. They stayed 20 minutes. They had planned for 30, but the sediment cloud and concern about the cracked port shortened their time. Then they came back up, and for the next 52 years, no human being went back. That gap wasn't a technical failure. The Trieste worked. The sphere held. The technology existed. The US Navy shifted its priorities, eventually retired the bathyscaphe, and the deepest place on Earth went unvisited by any person from January 1960 to March 2012. Since then, dozens of dives have been made. Since 2009 alone, scientists have published more than 3,000 research papers about that one trench. Almost none of it ever reached the public. So here is the question: what is actually down there? What did they find in the crushing darkness at the bottom of the Mariana Trench? And why is the answer both stranger and worse than most people expected? There is life at 31,000 feet. There are sediment samples full of organisms that have never been recorded anywhere else on Earth. And there is one more thing on the floor of the deepest place on the planet. Something that arrived before most expeditions did, that we put there ourselves, and that has been accumulating in the dark for decades. The Challenger Deep isn't an unexplored frontier. It's the most intensively documented place on Earth that almost nobody has looked at, and every expedition that has gone down has come back with the same two findings: life where it should be impossible, and our own chemistry already waiting on the floor. The Mariana Trench sits in the western Pacific, roughly 200 miles southwest of Guam. It runs approximately 1,580 miles north to south, a crescent-shaped scar in the ocean floor, but averages only about 43 miles wide. One of the longest geological features on the planet and one of the narrowest. You will encounter different depth figures for the Challenger Deep depending on which source you consult, and the range is wide enough to look like disagreement. It isn't. The floor of the Challenger Deep isn't flat, and that is the entire explanation. The Challenger Deep consists of 3 separate basins running roughly west to east: the Western Pool, the Central Pool, and the Eastern Pool. Each one is a distinct depression. Different surveys measured different basins at different times with different instruments, and that produced legitimately different numbers. The Trieste in 1960 recorded 10,916 meters at the Western Pool. James Cameron in 2012 reached 10,908 meters at the Eastern Pool. Victor Vescovo in 2019 achieved between 10,925 and 10,934 meters. The most precise current estimate comes from a 2021 paper in Deep Sea Research by NOAA's Samuel Greenaway and co-authors, derived from pressure sensors deployed during multiple submersible transects in June 2020. 10,935 meters, with a 95% confidence interval of plus or minus 6 meters. In Imperial, 35,876 feet, give or take 20. Mount Everest at 8,849 meters would sit inside that depth, with more than a kilometer of water still above its summit. Anyone citing a single authoritative depth figure for the Challenger Deep is describing one pool of a multi-pool system, measured once with one instrument. The honest range is 35,756 to 35,876 feet across the three basins, with the eastern pool apparently deepest and the best pressure-derived measurement sitting at the upper end of that range. Now, pressure. At the floor of the Challenger Deep, the pressure is approximately 1,086 bar. Converting to atmospheres, noting that a bar isn't the same as an atmosphere, gives roughly 1,071 atmospheres. In pounds per square inch, approximately 15,750. About 8 short tons pressing on every square inch of surface. Popular descriptions have reached for dramatic analogies here, and at least one widely repeated version claims the equivalent of 50 jumbo jets stacked on a single square inch. A Boeing 747 fully loaded weighs approximately 910,000 pounds. 50 of them is 45 million pounds per square inch. That is larger than the actual figure by a factor of 3,000. The real number, 15,750 psi, is already extraordinary. The reason it doesn't destroy water-filled biological tissue the way it crushes air-filled structures is that water is largely incompressible. A styrofoam cup sent to depth comes back the size of a thimble because the air cells collapse under pressure. Biological tissue, composed mostly of water, behaves differently. That distinction isn't trivial. It's the reason anything lives down there at all. Humanity's knowledge of this place began on 23rd of March 1875, when the three-masted sailing corvette HMS Challenger, midway through a 4-year scientific circumnavigation of the Earth, stopped at station 225 in the Western Pacific and lowered a hemp rope weighted with iron into the water. The rope kept falling. At 4,475 fathoms, 26,850 feet, it finally hit bottom. The crew took a second sounding at the same position to confirm. Both readings matched. They were, by the ship's scientific team's own account, astonished. The depth was named the Challenger Deep, honoring both the 1875 discovery by HMS Challenger and the 1951 echo-sounding survey by HMS Challenger II, which returned to confirm a much greater depth. From the first rope measurement to the first human descent was 85 years. For those 8.5 decades, the deepest place on Earth existed on charts as a number nobody had been within 5 miles of verifying in person. The Trieste's January 1960 dive was the culmination of Project Necton, a US Navy program of progressively deeper test dives in the Mariana region. The Challenger Deep dive was the final step. One detail about the descent deserves attention because it has been widely misreported. The crack at 32,400 feet wasn't in the main pressure sphere. The crack was in the plexiglass viewing port of the free-flooded entrance tube, a separate component, not part of the pressurized crew space. Walsh discovered its source only once they were on the bottom. Looking out the rear porthole, he identified a cracked acrylic window in the tube. The crack was caused by thermal stress and structural shift during descent, not by pressure failure. It didn't threaten the crew directly, but it meant that on ascent they would need to carefully blow water out of the entrance tube to exit the sphere, and Walsh later described the controlled bleed of pressurized air back into the tube as one of the more careful moments of the entire operation. What Piccard reported seeing on the bottom, a flatfish, a sole-like creature, approximately a foot long and 6 inches wide, half buried in the sediment, moving slowly before disappearing into the pale ooze, has been debated ever since. In 7 Miles Down, his 1961 account co-authored with Robert Sinclair Dietz, Piccard described it as a true, bony teleost fish, treating it as proof that vertebrate life existed at the greatest depths.
Walsh later said more carefully, "Neither Jacques nor I were trained biologists, and the critter could have been something else." Walsh also emphasized that it was Piccard, not him, who had the view through the forward port. In 2012, Alan Jameson at Newcastle University and Paul Yancey published On the Validity of the Trieste Flatfish, Dispelling the Myth, in the Biological Bulletin. Their conclusion, The sighting bears no scientific credibility. The biochemistry is the reason. Fish use a compound called trimethylamine N-oxide, TMAO, to stabilize their proteins against pressure denaturation. As depth increases, the required concentration of TMAO must increase proportionally. Near 8,200 meters, that required concentration approaches the solubility limit of the compound in fish tissue. The chemistry simply can't work beyond that depth. Every deep-sea camera survey conducted since 1960 has found fish stopping at roughly 8,000 to 8,200 meters. No vertebrate fish has ever been documented below that line. The US Navy's own historians now describe the flatfish report as generally considered to be erroneous. The most likely explanation for what Piccard saw is a large holothurian, a swimming sea cucumber of the species Galathiothuria aspera, white and oval-shaped, approximately the right size, and confirmed as a real Hadal inhabitant. Piccard almost certainly saw something alive. The animal he described as a flatfish was almost certainly a sea cucumber. After 1960, the Trieste completed further Navy missions, including locating debris from the lost submarine USS Thresher in 1963. Then it was retired. The deepest place on Earth went unvisited. On March 26, 2012, James Cameron piloted a submersible called Deep Sea Challenger, built in Sydney specifically for this purpose, to the eastern pool of the Challenger Deep. His descent took approximately 2 hours and 37 minutes, less than half the Trieste's falling time, because the Deep Sea Challenger was a vertical torpedo design, not a buoyant balloon. He spent roughly 2.5 hours on the bottom at a recorded depth of 10,908 meters. It was the first human presence in Challenger Deep in 52 years. Before the deep dive, Cameron's team ran test dives in the New Britain Trench. During those preliminary dives, Chief Scientist Doug Bartlett documented amphipods measuring 7 inches, 17 centimeters, long. Bartlett described them as the largest amphipods ever seen at that depth. They were feeding actively, apparently well-nourished, at depths that had not been directly observed by any person before. Victor Vescovo reached the eastern pool on April 28, 2019, in a titanium submersible called the DSV Limiting Factor, part of his 5 Deeps expedition to reach the deepest point in each of the 5 named oceans. His maximum depth, between 10,925 and 10,934 meters, is the current record for a crewed dive. Between April 2019 and July 2022, he made 15 total dives to the Challenger Deep, and the limiting factor carried more than 20 additional passengers over that period. On November 10, 2020, China's submersible Fenduze, Striver, reached the eastern pool at 10,909 meters, carrying pilot Zhang Wei and scientists Zhao Yang and Wang Jiqiang, the first Chinese citizens to reach the floor. Fenduze completed 13 total dives in the Mariana Trench between October and November 2020, 8 of them exceeding 10,000 meters. By July 2022, 27 people had descended to the Challenger Deep. The comparison that fewer people have visited Challenger Deep than walked on the Moon was accurate through approximately 2019, when Vescovo's program was just beginning. It has since been superseded. 12 people walked on the Moon. The limiting factor alone carried more than that. The framing survives in circulation, but the number no longer supports it.
The honest version is simpler. For most of the 66 years between 1960 and today, the deepest place on Earth was less visited than the surface of another world, because the equipment existed and the political will didn't. That isn't a mystery of the deep, it's a line in a budget. The biological picture that has emerged from 66 years of sampling looks nothing like the dead zone people assumed. Start with the fish, because the fish tell the most precise story. In 2014, research teams lowering baited camera traps into the Mariana Trench filmed a small, pale, nearly transparent fish moving through the darkness at approximately 8,134 meters, 26,686 feet. No scales, no visible pigment. Fins like translucent cloth, trailing behind a body that looked more gelatinous than vertebrate. In 2017, Mackenzie Geringer at the University of Hawaii and co-authors formally described it in the journal Zootaxa as a new species, Pseudoliparis swirae, the Mariana snailfish. Geringer said at the time, "This is the deepest fish that's been collected from the ocean floor, and we're very excited to have an official name." The species name honors Herbert Swire, the navigating sub-lieutenant aboard the original HMS Challenger who measured this place in 1875. 37 specimens have been collected from depths of 6,898 to 7,966 meters. Video observations reached 8,134 meters. That depth record carries weight because of what happens to fish chemistry below roughly 8,000 meters. Fish under pressure use trimethylamine N oxide, TMAO, to stabilize their proteins against pressure denaturation. The compound's concentration must increase roughly in proportion to depth, rising from approximately 40 millimoles per kilogram in shallow species to 261 in the deepest measured fish. Near 8,200 meters, the required concentration approaches the solubility limit in tissue. The compound can't dissolve at the concentration the pressure demands. Yancey and co-authors published this prediction in the Proceedings of the National Academy of Sciences in 2014. It's a biochemical prediction based on measured chemistry rather than an experimentally proven hard barrier, but it matches the observational record precisely. No fish has ever been documented below approximately 8,200 meters, including in multiple surveys of the Challenger Deep itself. A 2025 genomic study published in Cell by Xu and co-authors, examining 12 deep-sea fish species, found that while TMAO levels increase with depth in fish living between 0 and 6,000 meters, that trend does not extend below 6,000 meters, suggesting that other adaptations, including fatty acid composition in cell membranes, carry most of the load in the deepest fish. The ceiling remains real. The chemistry explains it. Below 8,200 meters, the ecology shifts. Amphipods of the species Hirondelia gigas, small crustaceans superficially resembling shrimp, are present throughout the Hadal zone and have been documented in Challenger Deep at depths exceeding 10,000 meters. Lower bait at any depth in the trench, and hundreds arrive within hours. Xenophyrophores have been observed in the Mariana Trench between roughly 9,000 and 10,600 meters. Single-celled protists, growing to several centimeters across, visible to the naked eye, functioning in conditions that standard cellular biology suggests should prevent it. Sea cucumbers, the holothurians that most likely explain the 1960 sighting, swim freely through the Hadal zone, documented by ROV surveys at depths beyond 10,000 meters. The chemosynthetic communities documented in a 2025 Nature paper extend the record further. Fenduzzi dives identified tube worms and bivalves living at depths up to 9,533 meters, 31,270 feet. The authors describe these as the deepest and most extensive chemosynthesis-based animal communities known to exist on Earth. They aren't fueled by sunlight. They run on chemical energy produced by rock-water reactions below them, the same serpentinization chemistry that drives the four-arc vent systems occurring in the trench walls and sediment. Nothing about the biology section requires dramatic language. The depth figures carry the weight. Life at 31,270 feet, confirmed in a peer-reviewed Nature paper in 2025. A fish species named after an 1875 sailor living at 26,686 feet, formally described in 2017. These are the facts. They don't need amplification. Between August and November 2021, the Fenduzzi team conducted 33 dives as part of an expedition designated TS-21. They collected 1,648 sediment samples from 145 separate sites across depth from roughly 6,000 to 10,900 meters.
nearly the full depth range of the Hadal zone. What they produced was a 92 terabase pair metagenomic dataset, the largest single biological survey ever conducted in the Hadal zone. Here is what matters about the number that followed. 7,564 species-level microbial genomes were recovered from samples spanning the Mariana Trench, the Yap Trench, and the Philippine Basin. Of those, 89.4%, nearly 9 out of 10, had never appeared in any public database. They were unknown to science before this expedition. Most of them are bacteria and archaea, prokaryotic microorganisms, single-celled, invisible to the naked eye, carrying no common name. Not fish, not worms, not any creature the word species usually evokes when heard in a nature video. A viewer expecting a sea monster and receiving a bacterium has every right to feel shortchanged. But the bacterium is the more consequential finding. These microbial communities are running the chemistry of the deepest environments on Earth, cycling carbon, fixing nitrogen, catalyzing reactions that sustain everything else in the trench. The 7,564 genomes represent the metabolic infrastructure of the Hadal zone, mapped for the first time. Published in Cell in 2025 by Xiao and co-authors, the dataset closes a gap in the catalogue of life that nobody had previously been able to close because the samples had never been collected at this scale. A parallel 2025 study in Science documented 32 new formally described taxa, agglutinated foraminifera and bryozoans, from hard substrates between 9,000 and 10,898 meters. These aren't genomic sequences, they are named species, each one placed in the tree of life with a formal description. Found on Fenduji footage and physical samples. Existing at depths that, a decade ago, were considered essentially barren of complex life. More than 3,000 scientific papers have been published about the Mariana Trench since 2009 alone. The discovery rate isn't slowing. The rock beneath all of this isn't passive background. On the Mariana Forearc, the region between the island arc and the trench, serpentinite mud volcanoes rise up to 2.5 kilometers above the seafloor, some reaching diameters of 50 kilometers. Patricia Fryer at the University of Hawaii has documented approximately 14 large active examples. These structures vent fluid produced by a chemical process called serpentinization. Seawater percolates through deep faults into the ultramafic mantle rock beneath the forearc, reacts with peridotite, transforms the rock to serpentinite, and releases hydrogen and methane in the process. The resulting fluid has a pH of 10.8 to 12.5. That upper range approaches household drain cleaner. In these fluids, methanogens and acetogens, microbes that metabolize hydrogen and carbon dioxide, have been identified and documented. Life in pH 12. The trench isn't an inert geological container. It's a geochemically dynamic system, venting high alkaline fluid from rock chemistry that has been occurring since subduction began, fueling communities on its walls that have nothing to do with the surface world.
In 2025, NOAA's autonomous underwater vehicle Orpheus, operated by the Ocean Exploration Trust and deployed from the exploration vessel Nautilus, completed dives to depths exceeding 5,600 meters east of the Mariana Trench, specifically east of the Commonwealth of the Northern Mariana Islands, and captured the first direct images of polymetallic nodule fields at those locations. These nodules are concretions of manganese, iron, nickel, cobalt, and copper that precipitate from seawater onto the seafloor over millions of years. Their presence in this region had been predicted by geologists for years based on regional oceanographic conditions. Direct imaging at these specific depths had not been achieved before 2025. What those nodules are worth, who holds legal claim to them under international seabed law, and what extraction would do to a seafloor ecosystem operating on timescales of millions of years, that question will require its own accounting, and it's coming. Victor Vescovo was at the bottom of the Challenger Deep in April 2019 when his cameras caught a plastic bag. Not near the bottom, on it, at close to 10,925 meters, the deepest point a crewed vehicle had ever reached. His team also observed food wrappers, manufactured debris sitting on the floor of a place most people have never heard of, in conditions no human industry has ever intentionally reached. The bag wasn't the finding. It was the visible symbol of one that had already been measured in the tissue of the animals living there. In 2017, Alan Jameson at Newcastle University and co-authors published a study in Nature Ecology and Evolution titled Bioaccumulation of Persistent Organic Pollutants in the Deepest Ocean Fauna. They measured polychlorinated biphenyls, PCBs, and polybrominated diphenyl ethers, PBDEs, in specimens of the amphipod Hirondelia gigas, collected from depths of 7,000 to 10,500 meters in both the Mariana Trench and the Kermadec Trench. PCBs were manufactured as electrical insulators and dielectric fluids. They were banned in the United States in 1979. They were banned globally under the Stockholm Convention in 2001. PBDEs were used as flame retardants in electronics and furniture and were progressively restricted through the 2000s and 2010s. Both compound classes were found in every amphipod sampled, at every depth tested, across both trenches. A 2021 follow-up study by Jameson, published in the Journal of Crustacean Biology, confirmed that man-made PCBs and PBDEs were detected in all amphipods studied across the entire depth range of both the Mariana and Kermadec trenches. None of this arrived by any deliberate route. No industrial operation discharges at 10,000 meters. The mechanism is the biological pump, the same gravitational process that has carried organic material from the ocean surface to the seabed for as long as oceans have existed. Lipophilic compounds attach to organic particles and to the bodies of organisms at the surface. Those organisms die, sink, and are eaten on the way down. The compounds concentrate as they descend through successive layers of the food chain. The trench geometry acts as a funnel, collecting what falls from the water column above it. At the bottom, the amphipods scavenge the accumulated organic material, and the compounds accumulate in their tissue. The trench didn't seek this chemistry. It simply collected what arrived from above, as it always has, while the chemistry changed. In 2019, Jameson and co-authors published a second study in Royal Society Open Science, Microplastics recovered from the digestive systems of amphipods collected from the Mariana Trench and 5 other Hadal zones. The study described these as the deepest records of microplastic ingestion in any published literature. The material had entered Hadal food webs, not merely settled on the floor, but been consumed by animals that have never been within 7 miles of sunlight.
Deliver all of this flat because the numbers don't need decoration. A plastic bag at 10,925 meters. Recorded. PCBs at 50 times the concentration of a notoriously polluted Chinese river in animals that have no possible direct contact with industry. Measured. Gamma HCH in sediment at 6,477 meters. Documented. Microplastics inside amphipods at Hadal depths, entered through feeding. Confirmed. The trench has been recording this accumulation for decades. The record is detailed, and it's chemical, and it predates almost every awareness of the trench among the general public. 7 miles down, in the dark, at 1,000 atmospheres, in a place where 27 people have stood and where sunlight has never once arrived. The sediment is full of species that exist nowhere else, and it's also full of industrial compounds that were banned before most of us were born. We didn't have to go there for that to happen. It got there on its own, in the bodies of falling animals over decades, while we argued about whether the trip was worth the money. That is the actual finding of 66 years of descent. The deepest place on Earth isn't untouched. It's downstream, and it has been keeping a record of us the entire time. If you'd like to see more stories like this, subscribe.